Most people think the AI race is happening inside software companies. The conversation usually revolves around chatbots, billion-dollar startups, futuristic algorithms, and the race to build more intelligent software systems. From the outside, artificial intelligence feels almost entirely digital. You type into ChatGPT, generate an image with AI, or ask a virtual assistant a question, and the response appears within seconds. But behind every modern AI system is a massive industrial infrastructure network most people never see. Because artificial intelligence depends on enormous amounts of computing power. Therefore, as AI systems became more advanced, demand for high-performance semiconductor chips exploded across the global economy. And today, much of that infrastructure depends on one small island most people rarely think about: Taiwan. Which means the future of artificial intelligence is now deeply tied to one of the most strategically sensitive regions on Earth. AI feels abstract because users only experience the software layer of the system. But behind every chatbot response are giant data centers filled with specialized processors performing huge amounts of computation continuously around the clock. Training advanced AI models requires extraordinary computational power. Some systems involve tens of thousands of GPUs operating simultaneously for weeks or even months at a time. Every AI-generated image, recommendation algorithm, voice assistant, and language model depends on highly advanced semiconductors specifically designed to handle massive workloads efficiently. Therefore, the companies capable of manufacturing those chips suddenly became some of the most important infrastructure providers in the world. But producing advanced semiconductors is unbelievably difficult, which is why only a tiny number of companies on Earth can actually manufacture the most advanced chips at scale. And at the center of that system is one company most people outside the technology industry had barely heard of just a few years ago: TSMC, the Taiwan Semiconductor Manufacturing Company. Today, TSMC manufactures a huge percentage of the world's most advanced semiconductors. Companies like Nvidia, Apple, AMD, Qualcomm, and countless others all depend heavily on Taiwan's semiconductor manufacturing ecosystem. Even companies competing directly against each other often rely on the exact same fabrication infrastructure. Because modern semiconductor manufacturing is one of the most sophisticated industrial processes humanity has ever created. Inside advanced fabrication facilities are enormous clean rooms designed to maintain nearly perfect environmental conditions. Tiny particles floating invisibly through the air can ruin production runs worth millions of dollars. Workers wear highly specialized protective equipment to reduce contamination risks. Temperatures, humidity, airflow, and vibration are all carefully controlled with extraordinary precision. And the machinery used to manufacture advanced semiconductors is almost unimaginably complex. Some lithography systems cost hundreds of millions of dollars each and contain thousands of precision components operating together at microscopic scales. Certain chip features are now measured in nanometers, smaller than many viruses. The manufacturing process itself can involve hundreds or even thousands of individual production steps requiring extraordinary levels of accuracy. But complexity creates barriers. Therefore, very few countries or companies possess the infrastructure, engineering expertise, supply chains, and industrial ecosystems necessary to compete at the highest level. Building advanced fabrication plants can cost tens of billions of dollars and take years to complete. And even with enough money, replicating decades of manufacturing knowledge is extremely difficult. Because semiconductor manufacturing is not just about buildings or machines. It is also about accumulated expertise. Entire ecosystems of suppliers, engineers, logistics systems, chemical manufacturers, precision tooling companies, and infrastructure networks must all operate together successfully for advanced chip production to function at scale. Which is why the global technology industry slowly consolidated around Taiwan's semiconductor ecosystem over time. Because, from a business perspective, specialization made economic sense. Instead of every technology company building its own expensive semiconductor factories, many outsourced production to specialized manufacturers capable of producing chips more efficiently and at larger scale. Therefore, Taiwan gradually became one of the most important bottlenecks in the modern technology economy. And the rise of artificial intelligence accelerated that dependence dramatically. Because advanced AI systems require enormous quantities of cutting-edge chips. Therefore, companies racing to dominate AI suddenly became heavily dependent on semiconductor manufacturing capacity, concentrated inside one geographic region. But concentration creates fragility. Because now, much of the global AI industry depends on infrastructure located in one of the most politically sensitive regions on Earth. China considers Taiwan part of its territory. Taiwan operates independently with its own government and economic systems, and tensions between the two have existed for decades, which means the future of global AI infrastructure is now deeply tied to geopolitical stability in the region, and the consequences of disruption could be enormous. If semiconductor production in Taiwan were interrupted, AI development around the world could slow dramatically. Consumer technology production could collapse into shortages. Data center expansion could freeze. Entire supply chains across multiple industries could face severe disruptions simultaneously. The world already experienced a smaller version of this problem during recent semiconductor shortages. Car manufacturers struggled to complete vehicles because essential chips became difficult to acquire. Electronics companies faced production delays. Prices increased across global markets. Supply chains slowed down because modern industries increasingly depend on semiconductors for nearly everything. And that disruption occurred without a major geopolitical crisis directly affecting the center of advanced semiconductor manufacturing itself. Now imagine a disruption involving the primary infrastructure behind the global AI economy, which is exactly why governments around the world are now racing to reduce dependence on Taiwan's semiconductor ecosystem. The United States passed the CHIPS Act to invest heavily in domestic semiconductor manufacturing. New fabrication plants are being constructed in places like Arizona and Texas. Europe and other regions are attempting similar expansions in order to rebuild long-term technological independence. But rebuilding semiconductor infrastructure is extremely difficult because advanced manufacturing requires much more than constructing buildings. It requires specialized engineering talent, advanced manufacturing equipment, stable electrical infrastructure, ultra-pure water systems, rare materials, complex supply chains, and years of operational experience. Some fabrication facilities require enormous amounts of ultra-pure water every single day. Others consume huge quantities of electricity continuously around the clock. Entire industrial ecosystems must function together with extraordinary precision for semiconductor manufacturing to operate successfully at scale. And unlike software startups, semiconductor infrastructure cannot scale instantly. Building new fabrication facilities often takes many years before they become fully operational. Manufacturing yields must be refined. Supply chains must stabilize. Engineers must develop operational expertise. Entire industrial systems must mature gradually over time, which means the race for AI dominance is no longer simply about software. It is increasingly becoming a race for industrial infrastructure dominance. The countries capable of producing advanced semiconductors may ultimately shape the future of artificial intelligence itself. Because behind every AI chatbot, image generator, recommendation system, and machine learning platform are factories, data centers, shipping routes, cooling systems, power grids, semiconductor supply chains, and industrial-scale manufacturing networks operating continuously around the world. Artificial intelligence may feel digital on the surface, but underneath, it depends on one of the most sophisticated physical infrastructure systems humanity has ever built. And right now, one small island sits at the center of much of that system. Taiwan did not become strategically important because of oil reserves or military size. It became important because it quietly built one of the most advanced industrial ecosystems on Earth. And as artificial intelligence continues becoming more powerful, the infrastructure behind it may become even more important than the software itself.